Okay, good evening. Okay, yesterday we were working on we stopped here. We are talking about serial communication, in vehicle communication, in vehicle or wired communication. Already we saw that it is always serial communication because we don't need to transfer megabytes of data per second except in case of video data. That also in serial communication most, correct, and FlexRay can transfer 150 megabits. Okay, that is serial communication. Now technology has come. So as I told you that we start to understand what is a serial communication. We start with RS-232, which we discussed yesterday. Okay, so it was the first communication system, serial communication system, which was used between many computers and telex, telegram, everything. Wherever digital communication that use computer equipments, all those things. We saw that in which, and I told you that data is transmitted using two wires. Okay, it is transmitted using two wires. The minimum speed was what you can transfer in minimum speed. Just 1 minute. There is a small issue with my system. I will may restart. Okay, be online. I will restart my system. I am facing some problem. Okay.
विकास कुछ बोल रहे एक मिनट जस्ट से समथिंग जस्ट होल्ड हाँ भैया बोलो
Yeah, hi Roshan, can hear you. Now cannot hear you, Roshan. Cannot hear you.
ओके जगन थैंक यू
Now can hear you. Yeah, now it's clear. Your voice is clear.
ओके ओके
Yeah, Professor said he has some problem with the system, so he's going to restart now.
Hello, can any of you hear me?
Yeah, Prem, you are audible to us.
Yes,
Okay,
Prem.
okay. Thank you.
PPT is visible now.
Yes, sir.
Yes, sir.
Okay, sorry, because there is a system of hanging. I don't know because there will be a lot of problem. Okay, fine. Yesterday we talked about this. I think I stopped here. Rahul.
Yes, sir. We stopped here.
Yeah, yes, sir. That's right. Yeah.
Okay, so we'll go to the next slide. So RS-232, if you see old generation computer, maybe 15 years or something, we call it a COM port. You will see a connector like this. One minute, there's a problem with my tab, writing pad, there's a problem. It is not accepting any commands. Please wait. Sorry, sometimes it happens. I'm facing some problem. Please wait. Sorry, I can't do anything. I'm again rebooting. There is some problem with my system. Let me check why this is. Okay. Kumar, it is visible? Is it visible?
Yes, sir.
Yeah.
Fine. Okay. So the RS-232 communication is very popular. Right now it is not used, but old general computers, they are very popular. So it is called COM port. Generally they call it as a short form. Colloquially they call it COM port. Okay. We are going to see that. Okay. So you know that there are two devices. One is called DTE, which is going to transmit data. That is a transmitter. Another device, it can be another computer, another ECU or anything. That is called the DCE. Data is received by this is the receiving computer. Okay. Now these two are connected by minimum 3 wires are needed. You can see that one wire called transmit. TX means transmitting data. RX is receiving data. Then ground. Because electrical signal you need a ground reference point. So minimum it will have 3 wires in RS-232. This is a duplex communication. What do you mean by duplex communication? Yesterday we had talked.
ECU can transmit as well as receive the data.
Yeah. This now I said this is transmitter, left side, right side a receiver. Now this can become transmitter and this can become this one. So data can flow like this. That's why you can see that each device, it can be ECU or a computer, whatever it may be. Each device has one pin called as a TX, other pin called RX, then ground. Now you can see that the TX of the transmitter is connected to RX, receiver. And the transmitter of the receiver is connected to receiver of the transmitter. So anytime one can become TX, other than RX, TX, RX, and TX are reverse. So it's called cross couple because the wires are connected. The TX of the first device is connected to RX of the second device. And similarly, TX of the second device is connected to RX of first device. So that means both can talk. But at a time only one device can talk. One device A is talking, others should receive. It cannot send data. Correct? So that is called duplex communication. Two devices can talk. Okay. So RS-232 communication, duplex communication. Both devices can share data. It is not one-way communication. Okay. Then I told you that if you see behind your computer or printer, plotter or equipment where RS-232 available, you'll see a connector like this. It is, you can see that this is pin number 1, 2, 3, like that. It comes here. I think it is a 14 something. Sorry, 13. Then 14, it is 25. 4, 5 like this. Right? You can see it will be printed. If you see very closely with the lens something, if you have very short weight, near each pin, the number will be written. Start from 1 to this one. So you can see here. So this is 1. If I keep this like this, if I take this and keep it like this, you can see it looks like a D. Correct? You need a D, A, B, C, D. Looks like a reverse, they call D connector. Sometimes they say D connector because it is shape. Why this is? It is so that you will not reverse connect. On the one side you have, you can see 13 pins. Other side you have only 12 pins. Correct? So you can. So this is called a male connector, which goes to one side of the one computer. For example, TX. This is nothing but female connector. It is called female connector. This is called as male connector. Wherever the pins are projecting, it is called male connector. Which this pin will go inside this one, mating. They call connectors mating. Correct? This is called female connector. One device will have male connector, other will have female connector. You can have both also, but generally it can be. So these two are connected by 25 wires. Each pin will be connected by 25 wires. So this is one thing. But versatile one or cut down version will have only 9 pins. This COM port can have 25 pin connector or 9 pin connector. Again, you can see again it is like a D only. One side 4 pins, other side only 5 pins. Correct? Both you can see that both are serial port only, RS-232 communication only, COM port only. But we know that for transferring data and RS-232, minimum 3 wires are needed. Minimum 3 wires. Okay. But while transmitting data, whether receiver receive data or not, and the transmitter has to what you call protocol. I told you, first send one signal, I am going to hello, like that. So for that, you have additional pins. You can see that these are the definition of all the 25 pins as per IEEE standard. In RS-232 communication, there are 25 pins. You can use only 3 pins, only 3 minimum pins for transmitting data. But if you wanted to see that the communication happens properly, safely, there are other pins also, which are called control pins. Here, we know that in RS-232, pin number 2, in the connector, pin number 2 is called transmit TX. This is the transmit data. Pin number 3 is receive data. Okay. Then you see pin number 7 is ground, GND. That's what we are talking. This is pin number 7. This is pin number 3. This is pin number 2. This is pin number 9. This is pin number. First is the transmit 2. 2. This is 3. Okay. So you see that the transmit, this is called cross coupling. The transmitter pin of the one computer connected to receive pin of the other computer. So vice versa. So both can communicate. Duplex communication. Other than that, you have other pins. So this is transmit. This is receive data. Already we know what it is. Then you have ground signal ground. This is compulsory. These 3 pins will be connected in RS-232 wire. Remaining pin, you can say one is chassis ground, body, to reduce our EMI noise. EMI noise, this pin number 1 of the both connector will be, if you see in RS-232 cable, most of the cable, you have an outer sheet, correct? Inside that there are 2 wires, correct? And then it will be the 2 wires will be enclosed by a braided copper shield. Copper braided shield. Braided means you know that ladies that hair they'll make a pigtail. They call braiding, correct? Like that, you will see that you see outer this one plastic or the sheet. You cut this, then inner side you will have one braided copper this one, which will be surrounding these 2 wires. Right? That braided wire will be connected to pin number 1, chassis. So any electromagnetic EMI noise comes, that will be shorted to the ground, body of your computer. So EMI noise will be connected. So that outer and the ground pin is the third wire will be there. 3 wires. One will be ground, one is RX, TX, minimum 3 wires. You can have up to 25 wires. What is the definition of other wires also? It is here. Similarly, this is the full connection. This is called as a full connection. Correct? So, because I told you the RS-232 was used for even fax, telegram, all those things. Correct? While sending fax data, all those things, you can see that they use what you call carrier. We are going to see later communication system. We are going to see the amplitude modulation, carrier, all these things to transmit carrier, clock, and many things were there. You can see that data terminal ready, correct? Clock transmit, test mode. These are to make sure that both devices are working properly. Correct? When I want to transmit data from here to US or to London, 5,000 kilometer, 10,000 kilometer, I want to see that my data is good. So they put additional signal to check the. We will see the when we talk about protocol. Okay, so this is full connector. This is the cut down version or reduced version. Still, this has 9 pins. So what are the 9 pins is defined here. Again, pin number 1 is protective ground shield. Correct? The pin number 1 of the one device should be connected to pin number 2, one of the same other device. So noise will be removed. Then transmit pin, receive pin. Then pin number 4 is called RTS. Correct? You can note down this. We will discuss this. RTS, CTS, DSR, signal ground. Then DCD, DCR, RI. So you can see that there are 9 pins. Correct? There are 9 pins in this version. Correct? This is the 9 pins. This also sufficient. Worst case, what you need is only 3 pins. With 3 pins also, RS232 you can transmit data, it will work. There are chances data may be corrupted, it may not work properly, correct? Because other signals are not there. So the other signals, the RTS, CTS, DSR, DCD, DTR, RI, all those things are called data control signals. Please note down, they are called as data control signals. Each one is separate wire, correct? This is, if it is there, it is good. You can ensure the proper communication, but minimum you need these 3 pins. Okay, 25 minutes still secure data transmission. You can see transmit clock, receive clock. There are many things, the carrier detect. These are used for transmitting telegram, fax, all those things. These pins are not for computer communication. RS232 were used for even telephone conversation, fax, telex. I'm talking 20 before the internet came. Having a fax is something like you are like a king. In IIT, only director office, dean's office will have fax machine, telex machine. Even professor will not have. I'm talking 30, 40 years before. Telephone itself will be available only to professors when I joined. Associate professor will not have the telephone. You won't believe. 1980s, 90s, only professor will have official telephone. That also no cell phone, landline. You can use only for this one. ISD is not possible. STD only possible. Because when I joined, once we want to talk something in Delhi, because I have to go to our head of department, only he had telephone, official phone, only professor will have. Professor can talk only inside Chennai, all those things. Even STD, you cannot, you have to go to HOD office. Internationally, you have to go direct to dean office. To talk phone, somebody I want to talk to US, I have to go direct to dean office, get a special permission. 1985, 80, I literally did once. I want to talk to one company in Denmark. For that, I went to dean office, waited, then connected to landline for talking 10 minutes. But if you talk 10 minutes per minute, that time you are charging around 40 rupees or 50 rupees per minute if you talk international call. Correct? So that time 40 minutes, now it equal to 400 rupees. Fine. That's why I'm saying all these things are, you'll see the RS232, there are many pins which a carrier, all these things are for transmitting telephone data, fax data, all those things. For computer communication, this is sufficient. These 9 pins are sufficient. Right? These 9 pins are sufficient. So that's why 9-pin D connector. You will see this kind of connector, this kind of connector. Both are RS2 compound. Okay, fine. Okay, what are the pins, the data pins we are talking? Right? CTS means clear to send. Please see that there are 2 devices. There's a device 1, there's a device 2. They are all connected by wires, these wires. Okay, so this is transmitting, this is receiving. Think like that. So, first device CTS means clear to send. Who is going to send? DCE. Please know what is the DCE. Already we know that DCE is nothing but receiver. Receiver is called a DCE device. Data is transmitted, DTE, transmitting. T means transmitting, this is communication receiving. DTE means transmitting, this you remember. So what it says, if this device, this pin is called as CTS pin. There's a separate wire. Right? What is it with this one? This is connected with this one. Now, normally this will be 0 volts. Okay. Then the D2 will make this, say for example, plus 12 volts. And send a pulse. How? you send a plus 12 volt pulse, one small duration. It is going to send a signal. That is the transmitter sees the device. This is called DTE device. This is called DCE device. DC is going to send this signal. Clear. I am ready to receive signal. What the receiver says, I am ready. Please send data to the transmitter. This is requesting. Receiver is requesting. Then one that is done, what will happen is, we will see how it is there later. First is clear to send. Next is data is deducted. Correct? This is for as per modems. For telephone signal, I told you this is all for telephone related. Telephone data, digital data to sending through telephone lines. Now, regular standard telephone lines to telephone exchange, modem equipment, fax, telex, all these things they will be using telephone exchange. So there you have to do what you call as a modem. So modem device also to be enabled modem, these signals are used. Then the data communication equipment. That is nothing other, again I told you modem. Okay. Then DSR, data set to ready. Okay. Who is going to do it? Again, this is sent by DC device. Receiver is going to send this signal. That means this is called DSR. This is like this. Please note that these two signals are arising from receiving device, which are CTS and DSR. What is the job of these? Data set ready, clear to send. So the receiver says that I am ready to receive signal. Please send my data. Who is requesting? The receiver is requesting the transmitter whenever he wants data. Okay. Then the DT is nothing but data terminal equipment or sending equipment, which is going to send the data. This is DTE. Okay. So it will send one signal. Yes, I am going to transmit. Okay. Like this, there are many pins are there. Okay. You see the transmitter is going to transmit. Transmitter data is using this pin. These two pins are called data pins. These two pins are called data pins. The remaining pins are called as data control. Transmission control. Control signals. Okay. So this is Jupiter. But right now we will see there are many signals which are not used in case of if you are going to computer, computer printer within short distance, unless you are going to use telephone lines and telephone exchange. Right? You can transmit because there is no need to put another wire from India to London to New York. Telephone lines are there last 120 years. Transatlantic cable was laid around 1900 itself. Telegraph, all those things. I'm talking 120 years before. Those wire itself you can use for transmit data between two computers. That's what they're doing for before internet came. Before internet came, they are using telephone exchange itself for transmit computer data also across continents. So that time you use modem, all those things. That's why there are many pins are there. Please note down. Just as this is information. Most important thing pins are, as we know that these two pins, these three pins are very important. And then we can see that other pins are, we'll talk about. Okay, let me go to next slide, then you will understand. Okay, now I wanted, these three pins are sufficient for understanding the RS-232 communication. Okay, so how the voltage in the RS-232 level, I told you what is the protocol bus, communication bus. It has physical pins, right? Then voltage level, then protocol. How start bit, stop bit, parity, all those things together called communication bus. In RS-232, the voltage level used to this plus 15 to minus 15. Okay. Generally, they use plus 12 and minus 12. But you can go as much as plus 15 and minus 15, but not less than 12 volts. Plus or minus 15 to plus or minus 12 volt you have to use. Okay. Now, already we talked, yesterday class we saw that we wanted to transmit data, correct? Serial communication, bit after bit. Okay. So that's what we are going to see here today, you see that this is the data I wanted to transmit. Okay, there are 8 data bits. Okay, please note that this is my LSB, this is my MSB. Okay, in RS-232, you need to, okay, here I shown it reverse. So this is LSB, this is MSB, this is start bit. Right? Then you have one parity bit. Yesterday we talked even parity, odd parity. Okay. Then I told you I can use 1 stop bit, 1.5 stop bit, 2 start bit. I'm using 2 stop bits. Nothing wrong in it. So how many bits are there totally? 8 plus 1, 8 plus 1 plus 1 plus 2. Totally 12 bits. If I want to transmit 8-bit data, I'll be using additionally 4 more bits. 1 start bit, 1 parity bit, 2 stop bits. So, but actual data is this one. Whenever we talk about efficiency, a communication system efficiency, communication system efficiency is nothing but number of bits, total number of bits transmitted, total number of bits transmitted, right, divided by actual data bits. That is efficiency. Multiply by 100% when we talk. So how many bits we have? I want to transmit actually 8-bit data, but in RS-232, it is compulsory as per the RS-232 standard protocol. There should be 1 start bit, there should be 1 parity bit, 1 or 1.5, 2 stop bits. We have decided to use 2 stop bits. That means 4. Okay, this is protocol bits. Then 8-bit data. So total number of bits equal to 12 divided by 8 into 100. This is the efficiency in percentage of RS-232 transmission. Correct? How much it is coming? Around 66, huh? Around 66%. Sorry, very sorry. Extremely sorry, it should be 8 divided by 12. Number of bits, actual data divided by number of bits transmitted. Very sorry, extremely sorry. So, number of bits, number of data bits divided by total bits, including into 100. So this is 8 divided by 12 into 100. Around 66% will come. Correct? But generally, what do we want? We want 10% efficiency. When you will get 10% efficiency? When you will get 10%?
This, if we don't have this stop and
only send the data. But if you send data, if they get corrupted, the receiver may not know. Correct? If parity bit is not there, the receiver think the wrong data. You send some information, everything goes because of EMI noise, some problem. Receiver owner, they will be interpreted wrong messages. Many times in war condition, this has happened in the Second World War and all. When data got transmitted, that fellow said, don't bomb, that fellow bomb because wrong information happened. Many stories are there. So that's why you have to add additional bit parity, start bit, all these things. It reduces efficiency. That is not good, but secure data, proper data is there. Okay, that is very important, correct? Efficiency is more important, more than the secure data, good information should come. That happens. Now, if I wanted to transmit...
Sir?
Yeah, yes, please.
Sir, I have... suppose 1 bit, sir, 1 bit only. In every bit we need to have 1 parity bit. Means every byte.
Every byte of data.
In every byte we have to we need to have 1 parity bit.
Yes.
So if the set
That's
of
not
information
compulsory.
is...
You can,
Yes,
without
sir.
parity also can transmit. RS
Yes, sir.
allows. But generally,
Yes,
it's better to save to do with parity.
Understood, sir. So my question is, suppose if the set of information has different bytes, okay, like the codes are different. In that case, how it will differentiate that first byte is correct, second byte is correct, means how the transmitter or receiver will differentiate that? Means not the transmitter, how the receiver will differentiate that parity bit is okay, next parity bit is not, means next signal is not okay, sir, because that parity may change, no sir, in based on the every signal, sir.
Yeah. No, parity bit is not, you are going to set, no. I told you, you have to set what parity you are using. You cannot use one time odd parity, other time even parity. You have to tell
Yes.
both transmitter, receiver, today we are going to use this. One stop bit,
Yes.
one start bit, even parity only.
Sir, but if it is means if the signal is of only one kind of signal is there, then
Now, what do you mean by
only
signal? I'm
one,
not getting your point.
sir,
Elaborate.
if we are
I'm ready
sending
to
the same
explain.
byte,
Huh?
sir, if we are sending the same byte
Hmm.
again and again,
Hmm.
then the set of codes will be same 10 100 10 something like that, sir.
Hmm.
If we are changing the byte, if we
Hmm.
are changing the signal,
Hmm.
then parity will change, sir, according to that. So
Why?
how?
Same data, if I send, how the parity will change? See, for example, same data you repeat 100 times. Right? This is my data. The
No,
parity
sir,
is
if
going to be same
changing
only.
the data, sir. That's what, sir. My question was like, if we are changing the data, because we are changing the signal, varying the signal, in that case, how it will means?
No, what do you mean by
read.
signal? I'm not getting. See, here signal
If we
means
are,
only data, no? What do you mean by the signal? This
yes,
is
sir.
the voltage level is called signal. That is
Correct,
transmitted
sir.
in one wire or a TX wire. This is what a TX wire. This is what you can see the minus 12 plus 12. Data transmission, it can vary between minus 12 plus 12. Okay, please tell me. I'm ready. This is very important. Good question.
Yes,
You
sir.
need to clear throughout your life. You should not forget. Okay.
Yes, sir.
Tell me.
Sir, see, whatever 8 bit is there, no, sir. One signal we are sending different set of 8 bits. Next signal we are sending different set of 8 bits. So in that case, how it will transmitter and receiver will
No. First,
read?
let me. I will today. We are going to. I will explain you. First, let me explain
Yes.
how data is transmitted. All these things. Then I will explain with you 2 or 4 different data how it is transmitted. That also.
Okay,
I
sir.
got
Okay,
your
sir.
point.
Okay, sir.
We will tell. We will see.
Understood.
Now,
Sir,
Thank you, sir.
yeah.
sir, within this only, if there are means in this particular data set, there are even number of one. Okay, so now parity bit is if we select odd, then it will be 0. Now, if I miss two data sets, means 2 bits are missed,
You can't
and
detect.
both are 1.
You can't detect. That's why only one bit error can be detected using parity.
Okay, sir.
But it cannot say which bit also.
Yes.
Correct?
Yes.
There is another thing, what you called as, this is error deduction code. Error deduction code. Parity bit or parity bit. Parity is called this. This is called only, it can detect 1 bit error. It can detect 1 bit error happen. Correct? 1 bit error alone it can detect. If 2 bits error happen, 3 bits are corrupted, it cannot detect. It can detect only 1 bit error. It can detect, but it cannot say which bit. For example, this is the data. This bit become 1. Received side 0 1 0 1 1 0 1. Now you can say what I transmit is 0. At received side received. Now my receiver will detect 1 bit error. Instead of that, if then 2 bit, 3 bit, it cannot do. That is one thing. Other thing is the receiver cannot know. See, this is bit number 0, bit number 1, bit number 2. It cannot say now B3 is corrupted. Okay. Instead of that, now what happens is this bit comes properly, but this bit is corrupted. Again, it can detect, but it will not know whether the B3 is corrupt, B4 is corrupt. It cannot say. Parity, if you use only parity bit, you can say there is a 1 bit error. If it is more than 1 bit error, it cannot detect. Even 1 bit error means it cannot say which bit was corrupted. B0, B7, which bit corrupted, it cannot say. It says there's a 1 bit error. So what is the receiver can do? Ask the transmitter, please send once again. Correct? So that is the difficulty with error detection code. Parity is a error detection only. There is error detection and correction code. Error detection and correction code. Because parity bit was first introduced, invented. After that, somebody said, okay, now what happens if something goes wrong? You request the transmitter again, send once again. So you waste of energy, waste of time. Now, if you have a code which can detect there's a bit error and which bit, then what is the bit? Bit can be 0 become 1 or 1 become 0. If once there's a bit error, and also you know which bit is error, bit number 3, 4, 5 it is known, then that bit value just reverse it. 1 means make it 0, 0 means 1. Easy. Receiver, you need not request the transmitter to send once again. Again, I need not send the whole thing. To transmit it 8 millisecond time, this voltage, current, power is wasted. I'm talking which is maybe milli microwatts. But if you're transmitting data continuously, phone, I'm talking continuously, somebody talking Chennai to US, correct? Every second, so many watts of power is wasted if you repeatedly sending. If I have a code which can detect what is the error, which bit is error, then I can correct also. Right? Error. So they call error detection correction code. Right? There are codes available, but that is beyond the scope of our course because I teach separate course for microprocessor and digital electronics. I was teaching from 2000 to 2015. There I teach for 8 to 10 hours about error detection, parity code, CRC. There are many codes are there. Okay, cyclic redundancy like that. There are, but we don't have time to discuss about it because we have to cover a lot of portion for us. Right? You understand that? Like this, there are something. I anyway will talk about CRC, right? Which is there used in case of CAN bus. CAN bus is using CRC, cyclic redundancy code. I will talk about that parity. Okay, fine. Now I want to transmit in the this is TX pin of the DTE device, which is connected to RX of the DC device. DC means receiver device. I know I told you this is how it is cross coupled, right? You can see here. Transmitter is connected to receiver of the second device. Transmitter of second device connected to receiver of the first device, cross coupled. So we are talking about the signal in this TX device. Okay. So normally in RS232, note down the voltage used is plus or minus 12 volts. I told you inside the computer, even microprocessor, i7 processor, memory, hard disk, data is what you call TTL level voltage. TTL level means 0 will be represented 0 volts by one logic high, which is called L and H. One is represented by 5 volts. Correct? I have a data 1010. It will be represented by as a voltage means this will be represented by 5 volts, 0 volts, again 5 volts, 0 volts. Right? So this is 5 volts, this is 0 volts. You can see that for 1 bit duration, this is 1 bit duration. 1 bit duration can be 1 millisecond, 1 microsecond, depending on what is the data transfer you have set. I said you 1 KB per second means it will be 1 bit duration will be 1 millisecond. It is 1 MB per second means it will be 1 microsecond. Right? So 1 microsecond, so 5 volt will be maintained at the TX pin, transmit pin. Right? Then 0 means automatically the voltage will become 0. This is how data is transmitted actually as a voltage level. So 4 bits are transmitted like 0 volt, 5 volt like this inside the computer. In case of RS232, it is transmitted as a plus 12 volt, minus 12 volts. That's what please see here. So this is called as timing diagram. Note down. In electronic circuit, it is called timing diagram or timing waveform diagram. They call timing waveform diagram. You can see that this is the reference. I'm drawing this. This is time axis. Right? This is time equal to 0, origin. This is voltage level. Plus voltage. This is minus V with reference to it. This is how you draw the waveform. Now, for understanding purpose, this is starting phase we are talking. You can say dotted line. It starts from here. We say that this is starting location. Now, I want to transmit this data. 1 0 1 0 0 1 0 1. This is my data I want to transmit. Okay. What voltage when this is my transmit, this is receive, RX. Okay. So what will happen? This wire, this is connected by single wire. Of course, there's a ground wire. Right? There's a ground wire. This, right? There are two wires are needed. This, I'm talking about DTE to DCE. Okay. This is the DTE, this is my DCE. Two pins are connected. Of course, the other pin is there. There's a transmit here that will be connected to like this. RX. Okay. The reverse happened. Now, right now, you forgot about this. We are talking one line only. So this we are not going to see this. Now, you can see here, first what you have to transmit? Start bit. You can see here, this is the start bit. In RS232, start bit is RS0. His value is 0. Start bit always 0. 0 in RS232 represented by plus 12 volts. Peculiar. A positive voltage used for 0. Logic 0 is represented by plus 12 volts. Okay. So before that, generally the voltage will be like the 0 volts. Correct? Before start bit, the TX, this pin, this wire will maintain 0 volts. Now, if the transmitter want to transmit data, means what it will do? Immediately, it will go to 12 volts. The TX pin will go to 12 volts. Somebody is asking question right now, correct? How it is going to know? Please note down this. Just now we are talking. I will said you explain also. I did not get his name. Okay. So generally the TX pin of the transmitter, which is connected to RX pin, will be ground is always 0 volts. This also will be 0 volts. For how long? From this period. That is called idle time. That is called as idle time. That means no data is transmitted. Okay. During that, 0 volts be there. Now, the transmitter wanted to transmit this data. It will not transmit data directly. I told you have to first send start bit. Start bit will be, what is start bit? 0 volts will suddenly become 12 volts. So receiver immediately knows that, okay, because receiver is watching. This pin is watched by the receiver computer or receiver card. 12 volts means it automatically recognizes it is a start bit. Receiver knows that if suddenly sees a 12 volts in the received pin, this pin, for 1 millisecond duration, then that is considered as a start bit. Right? You can see here start bit. It idle means it is 0 volts. You can see here this is actual waveform. This is actual waveform taken from this one. So it idle condition means 0 volts. Normally the voltage will be 0 transmitted by the transmitter. Now when the transmitter wants to transmit data, first thing it has to be a start bit. Start bit will be is a 0. Value is 0. That is represented by plus 12 volts. Suddenly voltage becomes plus 12. Okay. Then how long it should be? If it is 1 kb per second, that is data transmission speed, this duration should be 1 millisecond. For 1 millisecond, the transmitter will make that RX, the TX pin, which is converted to 12 volts. After that, it will start transmitting data. So 1 is represented by, logic 1 is represented by minus 12 volts. You can see that immediately the voltage came down to minus 12. From plus 12, it came to minus 12. This is minus 12. So how long? This will be 1 millisecond duration. 1 millisecond, the transmitter TX will maintain the voltage minus 12 volts. So receiver, if sees the RX pin for 1 millisecond duration minus 12 volts, immediately it recognizes this bit equal to 1. The second bit is nothing but 1. It is the LSB of this one, starting bit of the data. Once 1 millisecond over, it is watching continuously. Next bit is 0. 0 is up to plus 12. You can see that immediately goes to plus 12 volts. Correct? And it is maintained for 1 millisecond duration. So next bit is 1. So it comes to minus 12. You can see that that's how it is shown here. Note down this. 0 is represented by plus 12 volts. 1 means represented by minus 12 volts. So it last bit equal to 1. So it becomes 12. Now 8 bits are transmitted. Already told you, before transmitting the transmitter DT device, you have to set both the device equal to whether you are transmitting one start bit, how many data bits. Please note that in RS2 communication, you can transmit 8 bits or 7 bits. Generally, digital data is represented by 8 bits as a byte. Correct? But you know the keyboard, you are using a keyboard. The key is called ASCII keyboard. If you do a correct technical name, called ASCII keyboard. What is it? It is called American Standard for code interchange. Okay, so it is called as American ASC and I, and one more I is there. I will tell you. Okay, so the keyboard, when you press the key, A key, B key, number 1, 2, all those things. If you see there will be 128 keys. The correct technical name for your keyboard is ASCII keyboard with 128 keys. That is technically we need now. It is fixed because then to represent this is the 128 combination. Correct? So it uses 7 bit to maintain 128 combination. How many bits you need? 7 bits are sufficient. Correct? 2 power 7 is nothing but 128. Correct? So there are 7 bits. The bit 0, bit 1, bit 2, bit 3, like that. This is B6. Totally 7 bits. 7 bits are sufficient to differentiate different keys. Please note that when you press the key capital A, correct? Yeah, 7-bit code goes, for example, it may go like this. 1, 1. This is called A. When you press the key, A, the 7-bit goes from your keyboard. There's a wire connected to your computer through which your binary data 7-bit is transmitted to CPU. CPU immediately, by seeing you, if he sees this code, he knows that it is capital A. When you press the capital A, correct, with the shift and this will make it, then this is what transmitted by keyboard. Inside your keyboard, there is a microprocessor. Please note that. There's a small microprocessor inside. When you press the key, it generates this code, which is called ASCII code. American Standard Code for Information Interchange. Yeah, it is called as Information Interchange. Correct name is, I remember now. Correct? That is American Standard Code for Information Interchange. If you take, that is what it, because 128 keys are sufficient to represent capital A, B, C, D, 26 letter, then small a, B, C, D, this one, then 0 to 9 numbers, plus sign, minus sign, apostrophe, or whatever sign symbols you are seeing the keyboard. All those things, if you count, it will be 128 different combinations. So different combination, last many 111. It may represent small a something. Already, you can go to internet, you can ask for ASCII table. Google, you say type ASCII table, you will see a table which represents what capital A means, what your computer, the keyboard will transmit to CPU. Inside your this one, so that is, so it is 7-bit code. So I told you telex was there. I'm talking about 50 years before. I used to telex. Now nobody, everything is now internet, correct? So fax was there, telex. Telex uses the keyboard. Generally, there is no need for computer. There's a small micro directly connected to telephone exchange. It goes. Yeah, I type on this one. It will transmit ASCII code only. Because please see that many of the electronic devices, computer, calculator, equipments, all these things are invented in US, not in Germany, not in Japan. All the first invention will be many of the electronics for last 100 years happen in Silicon Valley. Right? Startup, new code, new. So they control. America controls what should be this one. I told you the FCC. Communication system is FCC. You see your cell phone also backside. You see the FCC regulation number something. Federal Communication Committee. ISO International Committee. This committee has to, many times you have to listen to FCC only. Whatever FCC says, this is final. That every country will accept. ISO is there, even the bigger country, Because money, when you have money, economy, military power, everybody have to listen to you. That's how it happens. Okay, the ASCII code was adopted by Americans because the computer came invented in first, even though it invented in England, Germany, everywhere in the 1960s, but finally ended up in the actual this one in Silicon Valley, America, right? So they introduced ASCII. So that means serial communication between two computers, you may send 8-bit data or 7-bit ASCII code. Any one of this is possible. 8-bit data or 7-bit ASCII code. So that's why when you are transmitting serial communication, as I told you, one start bit, 7 or 8 data bits, correct? Data bits, one parity bit, then 1 or 2 stop bits. Okay, then speed you can vary from 120 bits per second to 19,600 bits per second. All this thing you have to set before starting serial communication between two devices. Both there's a command. That command, using that command, you have to set your device. I am going to use 1 bit. I am going to use 7 or 8-bit data transfer. You cannot in between change. You have to be very clear. If you change, then data will not receive properly. Correct? And the speed, all this thing you have set. I will show the command right now before this one. One minute. There's a command called baud. Yeah, they're called mode command. You go to your computer, type CMD, correct? They're called DOS mode. There's a command DOS mode, and if you see there, if you want to change, you can use the command. Exactly, you have to type like this. This is called COM port 1. Correct? In a computer, you have 2, 3, 4 communication port because you have a printer, you have a plotter, you have a keyboard, correct? You have a mouse. I'm talking 25 years before USB came. All these things will be connected to CPU, main computer. So they are using RS-232. You will have 4 ports. Now you have 4 USB ports, 6 USB ports, correct? Like that, they will have COM ports. That time USB was not invented. So you will have, so which one, you can set a different speed for different. COM port 1 with different, this one, mouse is connected to COM port 1, printer is connected to COM port 2, plotter is connected to COM port 3. So you can use mode command, and you have to say which this one. You say the 9600 baud rate, number of bits, and no parity. N means no parity. You can say no parity. I'm not going to use parity. Don't worry. Then you say number of bits. Here I'm going to transmit data, not ASCII characters. So I'm going to transmit data, 8-bit data, byte byte byte. Right? Then this talks about stop bit, number of stop bit. Sorry, 1 minute. There is some baud rate. Yeah, no parity. Yeah. So 8-bit data, then the stop bit and the parity. We are talking what type of parity it is. P. Okay. So you can use this command. I can say mode COM to another port. I am connecting mouse. Exact. This is syntax. You cannot change. Say 1200, comma N, comma 7, comma 1, comma P. That means I am going to transmit 7-bit data, ASCII data, not this binary data, and 1 stop bit, parity is there. This is P. So this I am setting in my computer. This is the transmit DTE. Same thing you have to do in DC also. You cannot set different speed. This you set 9000. Here I said that instead of that I can put 1200. What will happen? This fellow will be sending faster because that means faster data. This fellow is waiting. So data receipt will be corrupted. So both you have to use same thing you have to do. Okay. Okay. So this is the voltage level lesson. You can see that this is how it works. Shall we give a break? Or continue on by another 25 minutes? I stop it. Whichever way you want, I can do that.
Just 5 minutes break, sir. That will be okay.
I will give 5 minutes. No issue. Thank you.
Okay, thank you, sir.
Hello, sir.
Yes, please.
Okay,
Yeah.
sir. Okay. No issue, sir. I thought that you were talking. I was not able to hear you. So,
No, not me.
okay.
If you are ready, tell me, we can start. Okay, we'll start.
Yes, sir.
Yes, sir.
Okay, so this is a voltage transmitted. So, sometime before somebody asked, correct? How if we transmit to this one, it's a different repeated. I don't remember. I told I will explain. Who was that? Okay, fine. Whomever, baby, I'm just trying to explain. Please see here, I'm trying to send the two different data. How, correct? One after another. So this is what I'm trying to show. You can see here. This is the first data. This is the second data. Right? So the data here, you have to transmit to start bit. Right? You have to start with start bit. Start bit is always 0. Correct? This plus 12 volts. Right? This is, sorry. Bottom is minus 12 volts. Now, start bit is transmitted for 1 millisecond duration. This is 1 millisecond because I am transmitting 1 kilobytes, 1 kb per second. Then my data is first bit is 1, 1 is represented minus 12 volts, B1 is represented by 0, that is plus 12 volts, B2 also is 0, so it is again represented by same plus 12 volts, B3 is 0, 1, so it becomes 0, this is B3. Then B4 is 0, again plus 12 volts. B5 is 0 plus 12 volts, 0, 0. Then B6 is 1, that become minus 12 volts. Again, last bit is 0. You can see that become this one. Then we need to change a parity bit. My parity bit is 1. So it is minus 12 volts. The parity bit is 1. So then comes these stop bits, correct? The stop bits is represented here. Okay, one stop bit. After that, 1 byte is transmitted. After that, what happened? The computer will not. If I want to transmit next byte, immediately I won't start. It gives a gap that is called idle time. Maybe for a few 10 million, 20 milliseconds, immediately not. So this 1 byte along with start, stop, everything is sent. After that, the voltage will be maintained at minus 12 volts for longer than 1 millisecond, say 10 to 15 milliseconds. Correct? At least 10 millisecond duration, it will be maintained at minus 12 volts. Why? What is this total duration for the transmitting this data? One start bit, 8 data bits, 9. One parity bit, 10. One stop bit. I said I am using one stop bit, 11 bits, 11 millisecond. Correct? So, worst case, 2 stop bits, 12 millisecond. For minimum 12 millisecond, but 30 milli something, I will give the minus 12 volts. If the voltage is at minus 12, they call idle time. Correct? So, the transmitter has to give a gap. It will not send next byte immediately. Wait for that is depend upon the speed. Now 1 kilobyte means you have to wait at least 12 millisecond gap. Will not transmit. After that, I start again next to start bit, next to data bits, parity bit, then stop bits, then again idle for 12 millisecond. So we know that the receiver knows that it is not receiving continuously to get confused. But whenever see for 10 to 12 millisecond minimum, there will be minus 12 volts. That means if the more than 12 millisecond, this is 0, then the receiver knows that the idle time. Data is not coming. Then immediately, then next to 12 volt, it goes to 12 volt for 1 millisecond. This is start bit. Plus 12 volt, it goes means automatically this is start of the next data. After that, whatever coming for next 8 millisecond will be considered as data. Correct? then parity bit, then stop bit, over. Again, it will become minus 12 volts, idle. This is because you want to transfer different data, no? You can transmit any data. See here what I turn 1010. But what is data I'm transmitting here? 1101 01 01 and 001. You can see that this data is different, this data is different. Correct? And I added parity bit based on, but you have to use same parity. For each byte, you cannot change the parity bit, odd, even, all those things. That's why I said you have to set for one transmission, you have to decide. Same thing should be used on both sides. Okay. Now, this is how you use how do you set the COM port speed, all those things. You have to use this command. Right? So baud rate can be 120 starting, 120, 240 also. Right? 240, 480 also possible, because 300, 600, these are the standard baud rate they use. Generally, it was up to 19,200 bits per second, but later they improved to double, up to this is maximum speed possible. Number of bits transmitted is 38,400 bits per second. This is maximum speed possible in RS2 to the latest generation, but now it is no more use because USB is taken over, wherein it is megabytes. Okay, so this is how it is. Stop bit can 1 or 2, 1 start bit, 8 or 7 data bits, correct? And all those things under will be using. Okay, so even now, if you go to your this one, you can go in Windows. You can see it. This you can see that port system. In the if you go to what to call control panel, correct? In the control panel of the Windows, correct? You can go and set the port, COM port. You can use this command. You can use this command using CMD mode, command mode, or you can go into Windows mode. You can go and select in the this one. Select this. You can see the COM1, COM2. That is nothing but serial. But now it is serial port. Please remember it is serial port, but still we call COM1, COM2. It is a serial transmission, but we are using USB. Okay. So you can see here. I have selected COM1 or COM2. Right. So there you can go and set this. Instead of using command word like this, in Windows you can do a drop down menu, which port number, whether COM1, port 2, what device is connected, what is speed. You can set. You can see that up and down arrow, drop down menu. You can set that this one 8-bit or 7-bit, whether parity is there or not, how many stop bits, all this thing you can set even in Windows mode. Okay, fine. So already we talked about it quickly. I want to complete today quickly. The RS2 works with a two-way communication that exchange data between two computers, because already told you that both the devices transmit and receive pins. Cross coupling. It is called as cross coupling. So that means using this you can transmit data. Similarly, this is both way it is possible. Duplex communication is possible. Okay. Then the data which is sending is called data terminal equipment, DTE. The terminal which computer which receive data is called data communicate, DCE, communication equipment. This is name in RS232. Transmitted, this is transmitted, this is receiver. Correct? Then this can become transmitted, this will become a receiver. The name will interchange. Which one is transmitting is called DTE, data transmission equipment, receiving given data communication equipment. Okay. Then there are data and control signals. Correct? Data signal are TXD, RXD. I showed through which data is transmitted. RTS, CTS, there are another 20 signals, correct? They are all called control signal pins. There is no need to use all the pins. Minimum you need, along with the ground, 3 pins and RTS, CTS. That's why 9 pins are used, right? Now already showed here. You can see here only 9 pins. 9 pin connector. Important pins are shown here. Correct? Protecting and shielding. TXD, RXD, RTS, CTS, DSR, ground, DCD, this one. This also not needed. You can still work RXD and ground. These 3 pins alone. Minimum is 3 pins are needed. Correct? Others are not needed. Other pins are used for whatever hardware handshaking. We are going to see today. They called as hardware handshaking. correct? When I meet somebody greeting, what I do, I extend my hand, I show my hand, correct? Also, I come on, hold, correct? Handshaking. Whatever you do, that's what in the computer also use same terminology. This is called a handshaking. We are going to see that. Please take the notes. In the exam, you may ask, write about RS-232, what is DTE, what is speed, how it works, voltage level, all these things you should be able to write. Right? That's why I'm covering slowly. Very important. If you understand it, other things are very easy to understand. Because very simple thing to understand. Then initially, how the transmission start? The DTE, right, is the source device which is going to send the data. For example, the RTS signal generates the request to send. Initially, from DTE source, the RTS generates request to send data. That means this signal will be normally 0 volts, that will become 12 volts. High. Okay, this signal will be sent. Then the receiving device, DC is called the receiving device. What it says, it sends CTS signal. RTS signal is sent by the DTE. I am going to send data. Get ready. Before sending data, this pin, please note that don't get, you have 3 pins. TX pin, then you have RTS pin, then you have CTS pin. Physically, there are separate wires. Don't get confused. Then you have ground wire. And of course, you have RX pin, receive. TX transmission, receive pin. Now, before transmitting any data here, what we saw, which one? This signal. This is transmitted using TX pin. This is before sending this start bit, stop bit, parity bit, all those things. What the transmitting device, this one you say that CTS, correct? So first thing is this fellow will be sending CTS signal. This will become 5 volts. Who will send? This is transmit DT device will send this signal to whom? To DC device. Hey, I am going to send data, get ready. After the 20, it will be transmitting 12 volt, minus 12, plus 12, all those things in the TX pin. First, it will send this one. And immediately, the receiver will, receiver will send this pin. Please see that with this is a time axis, right? First, this device sends this one. The receiver says, ready to receive RTS signal. It will send this signal, who the RTS signal will be sent by DCE to DTE. Receiver says, I am ready to receive. As I told him, hello, I am talking to Vikas. He said, yes, sir, please tell me, sir. Please tell me, sir, in a CTS signal. RTS signal, hello, Vikas. That is RTS signal. I am saying, I am going to talk to you. Immediately, yes, sir, please tell. Ready. That's it. You are not saying, sir, please talk. Okay. So that is like that. So that is called one that is done. Then I will send the TX pin. I will send this data 0, 1, plus 12. Which one? This one I will send. The whole thing I send for yes, 12 bits. Okay. Again, next time also I said. Now, if I use these pins, RTS pin, CTS pin, and after that I send this transmit signal, actual data using start stop bit. That is called a hardware handshaking. Note down. Hardware handshaking. That means I am sending signal as a separate. The pins are called hardware. Correct? That means I need, how many wires I need? 5 wires. TX, RX, RTS, CTS, and ground. 5 wires will be going between 2 devices. Because I decided to use the hardware handshaking. What is the advantage? Definitely, data will not be correct. A separate signal is going. With that, I am making sure that the receiver is ready. Before transmitting data in TX, I will tell the receiver, please get ready. And that fellow, if he is ready, he says, yes, I am ready. Suppose once I send the RTS signal by transmitter, if I am not getting CTS signal from the receiver, the transmitter will not transmit data. He will wait. I say, Vikas, I am calling 5 times. You are not responding. Correct? That means you are not ready. You are busy with something else. You are not wanted to, but there may be reason. Correct? I should not send, I cannot transmit data. I send RTS. If I don't get CTS, I will not send the data and the RTS. That is TX. TX, I will not send data, I will wait. Maybe wait for some, again I will send RTS. This is called a hardware handshaking. First, to make sure that you are ready to receive, and you say the yes sir, I am ready. That means by this one. Then I send the data. This is called hardware handshaking. Other one is called a software handshaking. Software means I will not have the RTS pin and CTS. I will have only both the devices will be connected TX, RX, and ground only. Only data pins are connected along with ground. No RTS. Only 3 wires will be there. That is minimum. In that case, I will send a start bit. Then I will dump data. Then I will send a parity bit. I will send a stop bit. Wait for 10 milliseconds idle time. Again, I send a start bit. This is called a software handshaking. Without using RTS, CTS, if I transmit data, that is called a software handshaking. Still handshaking is there. How? Anybody? If I use RX, TX alone, and there's a handshaking is there. How?
We have start bit and stop bit.
Start bit, stop bit. That is handshaking signal. They call software handshaking. Okay. Okay, that's what we are talking. How it this you can note down these points. This is expected in exam paper. I say how hardware handshaking data is communicated in RS232. You need to write all these things. First, what it sends, all those things. One more thing also, what you have to show? You have to show like this. This is I call DTE. Then I have DCE. This is nothing but receiving device. This is transmitting device. There will be one wire. This is called TX. Here, note down. This is called RX. TX of the transmission should be connected to RX of the this one. Then next pin, RX of the RX should be connected TX of the this one. Then I will have CTS signal. Then I will have RTS signal. Then ground signal. 5 wires are there. This is for hardware handshaking. In hardware, actually, I told you, if you modem and all, if you are using, you have to use all other pins, right? All these pins you have to use, carrier signal, all these things. Through telephone, I'm using modem device, right? If I through telephone, actually, I want to connect two computer from India to say Chennai to Bombay, Chennai to Bangalore, telephone exchange, I will be using more signal. I need around 24 wires, right? Very complex. From me to telephone exchange, right? Up to telephone exchange, I will use these pins. Correct? Our telephone line. After that, telephone only 2 wires are going. Telephone exchange converts all this thing appropriate. There's a lot of things happening in that way. But we are talking about computer to communication. So in that case, this all is needed. The only we need 3 pins or 5 pins. Because somebody, if you go for interview, somebody asks, do you know RS232? What is the hardware handshaking? You say that only it is RTS, CDS along with TXT pin, that is called a hardware handshaking. If I don't have RTS, CDS, this is called as software start-stop bit. They may ask, what about the SCTS, RXT pin, correct? There are other signals, no? There are many signals. What about that? You say that it is used for modem. When I want to transmit data between two telephone lines, right? Between 2 computers, I don't need this thing. So these are also for hardware handshaking only. Many things will happen. Apart from CTS, RTS, this also you have to use if you are using telephone exchange. But if it is a 2 computers nearby, right, within a building, next building, right? So within 500 meters, right? Within 100-meter distance, 2 computers, RS2 if you're using hardware handling, you have to use RTS, CTS along with TX, RX and ground, 5 pins. If you don't want to software handling, means you don't need RTS, CTS also. Only 3 wires are sufficient. Okay, you do that. Yeah. Because in interview, somebody may ask, I'm saying my thing is if I teach, I wanted to see that you know, understand everything. It's not, see, but there will be variation happen. For more information, you have to read. Right? I'm giving the basics only, I'm teaching. Okay, then we will talk about parity. Right? Already we talked about parity. Parity checking is called error detection method or error detection code. Correct? Okay. For example, I want to transmit, already we know that my data 5-bit data. I want to transmit with even parity. Right? With even parity. Okay. Then resulting final bit will be, how it will be, you count number of ones. You correct? Count number of, how many ones are there in the 5-bit data?
3.
3, correct? 3 bits are there. Then this is my parity bit, correct? So what should be the bit?
Odd.
It should have been 0, sir.
Fantastic, Vikas. Very good. I wantonly made 0, 1. So whether you're, that's why here I mentioned even parity. What should be this? This should be 0. Because already we talked, that's why I just made this correction today. I wantonly made, whether you understood. This should be 0. Suppose I have another data, 1 0 1 0 0. What will be the data? What will be the please, while transmitting, I will transmit data with parity. Of course, there will be a start bit and stop bit. Right? But generally send as 8 bit or 7 bit only. For understanding purpose, I said 5 bit. Now, what will be the transmitting code for this? Even parity means.
It will be 1, sir, because there are 2 ones.
Yeah, 1 0 1 0 1. This is what will be transmitted along with start bit. Sorry, this will be start bit. This will be stop bit. After parity, stop bit will come. The data will be transmitted like this. First start bit, then this bit, right? This is parity, then stop bit. Right? So this is how it will be transmitted. If it is corrupted, already we understand, yesterday we saw that. Okay, receiving computer, how it deducts? What it will do is, we know that already I told we are going to transmit 8 bit or 7 bit. So please see here. Already we are saying 8 bit. Right? And one stop bit, one start bit is always fixed as 1. Stop bit alone you have to say. This one, this can 1 or 2. Right? You can see here baud rate, speed, then parity. Whether parity is there, parity, even, odd, or no parity. It can have N, O, E. Parity, even or odd parity. Okay. Then data. Right? How many bits of data? Whether it is a 8 bit or 7 bit. Then stop bit. You can see that start bit, there's no start bit in the command. Why? Start bit is always 1 bit only. Compulsory that there will be one start bit, that is called starting. Stop bit can be 1 or 2, we are mentioning 1 or 2. Right? So then there's a retry. Right? P is called retry bit. Last bit is called retry bit, that is for XOR communication. Correct? You can set this. If data is corrupted, what I told you? You are sending the parity. The receiver finds that there's a bit correction. What it has to do? It should request the sender again send me. Correct? So if you want to enable that is called XOR protocol. Automatically, if the receiver finds the data corruption by checking parity bit, it will ask this one. They call XOR. They call software handshaking. If I set this bit, last bit, additional one more bit, so automatically it will happen. Whenever corruption happens, the receiver will say, please send the data once again. Okay, that is called software handshaking. Okay, so you can see that how it works. Note down this, how it works. We are talking. So they transmit when the data comes. What this will do is it will strip down. The receiver will take only the data bits. Start bit it will ignore. For first 1 millisecond, whatever it comes to start bit, it will not take. Next 8 milliseconds, because I already said 8 bits. 8 millisecond data comes, that will be registered. Here it will be 5 milliseconds, 5 bits. Correct? The next bit is called parity bit. It automatically knows that next is parity bit. Okay? So it will then it will do the parity checking for this. For this 5 bit, it will check parity checking for even parity. And it generates. Now what is this? 1 1, it is 1. Correct? Even parity, there are 2. Correct? Now there's something wrong. That means it will say that is wrong. This is how it works. Okay. So received bit. So in the exam, what do you expect? I'll give, for example, 1 0 1 0 1 1 0 1. Correct? Use even parity or odd parity. Correct? With 2 stop bits from the data. And this is transmitted with even parity. Okay. Stop bit, you need not worry. Use even parity, generate the final code. What is the even parity for this?
It should be 0.
0.
Sir.
So this is parity bit. This will be 0. Okay. So this is what you have to generate. Now, I say that this is transmitted. At the receiving side, I received 1 0 1 0 0 1 0 along with 0. Whether error is there, you have to detect. Again, receiver also will do same thing. Whatever you did for generating parity, same thing receiver also will do with the data. Then it will compare with this. For example, compare with this. Here it generates 1, correct? Here it is 0, correct? That means data is wrong, correct? The received data, there's an error, correct? There's a parity is generated. Instead of 0, it is 1. That means the received data is corrupted. Automatically, the receiver will ask this one to transmit data. Okay. Already talked about handshaking. No handshaking, hardware handshaking, software handshaking. Already told, correct? So 3 type handshaking possible. No handshaking, software handshaking, hardware handshaking. Already we talked about it. So that means you can see that 5 wires are needed. The hardware. Yeah. If there's no handshaking, then DC already received data while transmitting. There's no checking business, just dumping. Data will be just dumped. Correct? That's not good. No handshaking. Sometimes they use, if you are not worried about data, just you use it. Right? So this you forget it. What I want to do, hardware handshaking uses RTS, CTS. Already we know. Correct? Uses. This is generator. Who is generating this? RTS.
Transmitter.
Yeah, DTE equipment.
DTE.
DTE. One, this is sent in this pin, separate pin. Please note the separate wire in which the DTE sends the signal to this is receiver, this is transmitter. Then the after some time, once this is received, if the receiving signal ready, it will generate 5-volt pulse. This will be sent to the transmitter. This is sent to receiver. Once this is received, the DT will send the data. We stop it. This is data. Please see the sequence. First, RTS signal sent by DTE, and if the DTE is ready, it will send the CTS signal. If CTS signal is received by this one, then it will send the data. Otherwise, it won't send data. They were hardware and syncing. Okay.
Sir,
So, yeah.
is this RTS and CTS signals for every byte or
Yes,
for a set of
byte,
data?
every byte.
Okay.
Every byte it will do that. But it's secured communication. But you need 2 more additional wire. Your cost of the wire increases. If you are going to 100 meter, 1000 meter, correct? So 5 wires are no initial cost is a little higher, but it's secured communication.
How fast does this take place?
I told you it can be 120 bits.
Milliseconds.
No.
In terms of time, sir?
What is speed, baud rate.
Yeah.
It can be 120. That means 1 divided by 120 seconds.
Okay.
So they very slow speed. Can
Got it.
do 36,000. 1 divided by 36 seconds. The highest possible speed. 36K. Normally 19.6. 19.6, if I'm correct. 1 minute. Already we saw. Yeah. 19.2 is standard. The latest RS-232 38.4K. 30. This is dead slow.
Noted, sir. Thank you.
Okay. Then next one is called software handshaking. Correct. Then software handshake also there another version is there. Yeah. The software handshaking is I told you no handshaking means we are using no handshake this at all. No RTS, no CTS, only start-stop bits alone. That is called no handshaking. Right? Then comes the third one is called is software handshaking, which uses XOR character. Okay. What it uses is, you can see that it transmits, the handshaking method is there are 2 characters use special character. Before sending actual data, the transmitter will send a special character which is called XOR character. Correct? If you send that, transmission will be ready. Correct? XOR. When you want to stop this one, you'll send the XOF character. There are two special characters. Those characters are, you can see here, they called as this. This is number, ASCII code. Before starting transmission, the DTE will send this code. No RTS signal, no CTS signal, only RX, TX and ground. But before transmitting the actual signal, start bit, data bits, parity bits, stop bits, it will send this special character. If we send DC3, right, the decimal, so you can see that binary value is like this, 0001, 0011. This is binary. This is nothing but DC3. Right? The character is this. You can say hexabyte. So this byte, this information is sent first. After that, the data will be sent along with this one. So this is called Exon character. They call software handshaking. Whenever similarly to okay, first you will the DT will send this data, this byte, right? This special character. After that, it will send the actual data. Now, if you want to stop, means it will send this number 0001 and 0111. This is XOF character. That means I am going to stop transmission. This is Exon character before sending actual data. Right? The DT will send this byte. So the receiver will ready. They call Exon character. And send the number of bytes. Maybe
so these two bytes are fixed, sir.
That's what this is already fixed in RS-232. You have to send what you can see that hexadecimal equivalent. This is binary equivalents.
Okay.
This is called as a software handshaking Exon character. No handshaking means that means no RTS, no RTS, DTS, CTS, no Exon center. You directly send data.
Sir, but one thing I want to ask you, suppose you have defined that 13 and 11 are the hex number which is converted into binary number and that is sent as Exon or XOF, right, sir?
Yes.
Suppose there is a next bit which is 11 only in that way, which is data, actual data. The next byte, the bit which is going to be sent by the DTE is suppose same number.
But which one?
What I mean to say, sir, XOF and Exon, they define number 13 and 11 for them, right, sir? So once this is sent, the DTC will be informed that okay, I am sending data to you. DT will say that.
Yeah.
Right, sir? But what I mean to say is, suppose even after 11, there is a number which is 11 to be sent.
Yeah.
Data.
Fine. Please note that this is the 8-bit data. The Exon character is 8-bit data.
Okay.
Okay. But you can see here, that's why good thing you asked the question. Exon XOF will be used only for transmitting ASCII code. ASCII code is 7-bit data.
Okay.
7-bit data plus 1 start bit plus 1 or 2 stop bits plus 1 parity bit. The Exon is 8-bit data. Please know the Exon can be used only for transmitting ASCII code, which is 7-bit code. This is a special mode. It's called software handshaking. Okay, you can see it. So it is used only for transmitting ASCII code, not 8-bit data. Generally, the data is generally 8-bit. This is a ASCII code. Whatever typing, for example, I am typing Word, correct? What you are typing, keyboard. I stored a Word file, correct? Word file is stored as only ASCII characters. It is 7-bit code on the keyboard, small, capital, all the keyboard, correct? It is not a. So if you want to transmit, I can use only for that. You can use. That's why I use this specifically.
Okay.
So start bit is here. Exon will be 8-bit. XOF also 8-bit, but data will be 7-bit with the start. All those things. You understand?
Thank you, sir. Thank you.
Okay. So now I wanted to close. I know the time is up. I want to close today. So RS-232 bus uses ground, and then one more thing also is the main important thing is inside your computer. In computer, the voltage is 0 or 5 volts. Okay, but there's a computer 1 and there's a computer 2. Just 2 minutes, I'll stop. I know already today it take a longer time. So this is the receiving computer. So inside the computer, you are working 0 volts or 5 volts to represent binary data. But before transmitting, you have what you call RS-232 transmission receiver, trans receiver IC. That you will be sending 0 volts or 5 volts from the computer. That will be converted to plus 12 volts, minus 12 volts by this IC, special IC. Actually, these two IC only is connected by wire. Inside your computer, there's a special wire vertical RS2 transmit. So from the CPU, plus 12 5 volts coming, that will be converted to plus 12 minus 12 by a special IC. You need not worry, I'm just saying there's a special IC inside each computer. From there only the connector is connected. The RS-23 connector is connected. So in the wires, you will see plus 12 minus volt. But once it goes inside, it converted again 0 volts, 5 volts and sent to CPU. CPU work was the TTL level signal. Inside the computer, 5 volt, but this one. So binary 0 works with plus 12 volt inside the computer. Correct? When it comes, it will be plus or it can go up to plus 15 volts. Okay. Generally, they use plus 12 volts and minus 12 volts. That's what we are saying. 2 on. Correct? So binary works with received signal up to the voltage level, all these things. This you need not know. We know that it is you can just know what it is. That's it. This slide is not important, but maximum speed is around 20 kilobits or 36 already we saw. The number already you saw. Okay. Main thing, future is it use only 2-wire communication. Correct? Minimum 2 wires plus ground. So cheaper. Long distance, because wire cost is less, thousands of kilometers. Please know that if I want to transfer RS-232 for two computers can be connected up to 1000 meters. Between two computers, 1000 meters is allowed. Correct? But if the two computers beyond, say, 2000 meters, 5000 meters, what you have to do, you have to use a repeater. This is the computer 1, this is computer 2. This is, for example, 2 kilometer total distance. In between, I use what you call a repeater. So first 1000 kilometer, one repeater. Nothing you will do. Whatever there, the word will be again repeat and send it to computer. From here to US means you can see how many repeaters are needed. 10,000 kilometer. Right? 10,000 repeaters will be there to transmit RS-232. Right? So that's what it is. Asynchronous communication. Okay, there's no need for clock. Okay, then maximum communication is 15 meter. They say there's a different this one. Depending upon this one, there's a 15 meter once repeater is needed. Right? They say 1000 meter repeater is needed. Right? So generally, for good quality communication, every 15 meter, 20 meter, you have to put a repeater. I have worked up to 100 meter without repeater. Inside my building, 100 meter, because RS-232 some 18 years before, I connected one device in my lab to my computer, my room, which was around 50 to 60 meter distance. Still it was working. Okay. So received signal data can convert to parallel communication, shift all those things. So it uses what you call a duplex, full duplex. Okay. So last slide. I told you synchronous communication. We are not going to explain this because we are not going to use this. Even RS-232 we are not using inside vehicle. But for you to understand and explain, you can see that it is used between two CPU or two microprocessors if you're using your embedded controller. Special some microcontrollers what it calls SPI communication called serial peripheral interface. It is a serial communication, but it is a synchronous communication. You can see here. This MOSI, MISO are the data, actual data. The SCK is called a clock signal. You can see that it sends a clock. So this is a data. For every bit, it sends a one clock. I am transmitting 8 bits of information. This is data. I am transmitting one device. So for every this one to enable, there's a clock. So that means you need one more wire. But what is the advantage? what it does is the receiver will, during this period, which is called a rising edge of the clock, it will look what is the data value. Correct? During this, you can see that there's an error. During the, what is the voltage level? This is 5 volts, 0 volts, 5 volts. Here you can see that every clock, this is 5 volts. This is 5 volts, this is 5 volts. Here it is 0 volts, 0 volts. Again, here it is 5 volts. Here it is 0 volts. Correct? It is 5 volts. Here it is 0 volts. So the receiver will check this is data only during this transition period. Whatever value is there, that time, whether 0 volts, 5 volts will be taken. Accordingly, the data will be interpreted as 1 or 0. So this is called synchronous communication. You can see that every time when data is transmitted, correct, you are sending clock also. So you need additional wire. Correct? So this is generally used inside the computer only, not outside, generally. Okay, I'm not going to ask. This advantage is 4-wire communication. Ground, transmit, receiver. MISO is, SI is, I means input, O means output. The output is connected to input, again vice versa. You can say data is transmitted at this one. Okay, vice versa, and clock. Okay, this is how it works. But it is high-speed communication compared to it uses 4 wires, where 3 wires are used in RS-232. Okay, and it supports multiple devices. In RS-232, you can connect only 2 devices. No doubt. Only 2 devices can be connected by RS communication. You cannot connect 3rd device. That is device 1 connected to device 2. I cannot connect device 3 here or device 4 like this. Multiple devices are not allowed. Only 2 devices possible. In SPA, you can connect multiple devices. Okay. Please note that this we are not using. You can see here, this is 1 device which is transmitting. There are 2 slave devices. In SPA communication, data who is sending is called masters, others are called slaves. Correct? Master is sending, 2 slave devices are listening. And tomorrow we'll see what the advantage of SPA, disadvantage, and compare. Then we start CAN bus tomorrow. Okay. So this is introduction of wired communication yesterday and today. Tomorrow we start about CAN bus and LIN bus, which is used in autonomous vehicle. Okay. See you tomorrow. Sorry, today I took little because class started late. We was another meeting. I could not do anything.
Is it perfectly fine, sir? Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Yeah. See you
It
tomorrow.
is for our benefit only, sir. Yes, sir. Thank you, sir.
Thank you. Kind of you. See you tomorrow,
Yes.
5 o'clock. Give
Thank
your
you, sir.
attendance. Okay.
Bye, sir.
Yeah, thank you.
Thank you.
Thank you, sir.
Yeah.